Example 5. Light rays directed at the focus of a hyperbolic mirror are reflected to the focus of the other branch of the hyperbolic cross-section of the mirror. A hyperbolic mirror is shown. So what's happening here is our mirror is down here at the bottom, and we're going to take a light ray and we're going to shine it into the focus of our bottom one, and it gets reflected off the mirror back to the focus of the other part of the hyperbola or the other branch sitting at the top. Part A, write an equation of the cross-section of the mirror. So in order to write the equation, the first thing I'm looking at is I'm looking at the fact that this hyperbola is cutting through the y-axis. So I know this guy's going to start with a y squared. The next thing I'm looking at is that the center is going to be at the origin. So our standard form is going to look something like that. If I go on my transverse axis from my vertex to the hyperbola itself, they're telling me that's 3 centimeters. So I know A is 3. And then on the other side, if I go from the vertex into the focus, they're telling me 4. So in order to get to my focus, that's my C value, is 4. That means I still need my B value. So we know C squared. Sorry, just a second. Oops. Well, that's not going to work. So C squared equals A squared plus B squared. C is 4, so we know this is 16. A is 3, so we know this is 9 plus B squared. 16 minus 9 is 7. And again, we don't need to go further here because in our equation we're just going to put B squared, which is 7 anyway. So y squared over A squared. A is 3, so we know this is 9, minus x squared over B squared, which we just found was 7, equals 1. Part B, how tall is the mirror? Now, keep in mind that the mirror is on the bottom here, so we're trying to find how tall it is. The height of this mirror is going to be from this vertex down to the bottom of the mirror. So we're trying to find that height, how tall the mirror is. Now, in order to do that, I'm first going to look at this part, because maybe I could find this point. I know this point is at -3, because it's down 3 centimeters. Well, what if I could find how far down this point is? Then I would know from -3 to wherever that is, that's going to give me my height. Well, that point down there is sitting right there. And that point occurs when x equals 4, because this whole distance is 8. So that's 4 and that's 4. So when x equals 4, the question becomes, well then what's y? Because that'll get me down to that point. In order to find that, I'm going to use my equation. So my equation, we had y squared over 9 minus x squared, which we're going to substitute in a 4, equals 1. Then we're going to have y squared divided by 9 minus 16 over 7 equals 1. We're going to add 16 over 7 to both sides. So y squared over 9 equals 23 over 7. Then we're going to multiply both sides by 9. So y squared equals 207 over 7. Then we're going to take the square root of that. And we're going to get y is roughly plus or minus 5.44. Now, what that's telling us is that we could either go from here and go 5.44 or 5.44. But because we're on the bottom, I'm going to choose that this point down here is at -5.44. but that's not the whole height of the mirror, because remember, we just want in between here, and that's already at -3. So I'm going to take -3 minus -5.44 to really see the difference there. Those are going to become positive. We're going to get 2.44 centimeters. So the height of the mirror in there is 2.44 centimeters.